So when we're looking at windmills 2, we're given all this information. We have to take whatever information is given to us, and we know what we're doing is we're going to draw 2 graphs. It's nearly always 2 graphs because we're actually looking for intersections in these 2 graphs over the period of whatever we're being asked to do. So in the field there are 2 windmills, a large one and a small one. So we're going to call them the large one and the small one so that we know which ones we're talking about. The sails of the large windmill reach a maximum height of 50 metres and a minimum height of 16 metres. All right, so you all know what a windmill is. I don't need to make you draw a picture of that. So from our point, let's not even go there. So depending on what numbers we've got, we need to think about our axes. We don't need negatives. We're not going backwards in time to look at what happened before. Sometimes we could have to, but in this one we're not. What we're interested in is the height of a certain point on the windmill. So Emmy's putting a smiley face sticker on each of the sails right at the bottom. All right, and then she watches the stickers go round for 5 minutes. So we're going to have 5 minutes along here. All right, that's our time. And up here we've got the height, and the highest one is 50 metres. So this is going to be 50, and this is a sketch, guys. I don't care about the accuracy of it, all right? So the first one goes from 50 to 16. So I'm just going to 30, 20, 10. So 16's about here somewhere. All right? And we'll worry about the next bit in a minute. And the other one is going from, now the diameter of the small wheel is 4 metres and they're attached 20 metres above the ground. They are attached 20 metres above the ground and the sails of the small wheel make So 20 metres is the lowest point. Oh no, 20 metres is what? The diameter of the small windmill. Here he is, Mr. Small Windmill. All right. So the diameter is 4 metres. And they're attached to the windmill 20 metres above the ground. All right, so if we pull that over onto our graph, all right, what is the 20 metres? It'll be the middle, right? It's going to go round and round or up and down from there. So 20 metres is the middle of this one, and then it's going to be the top is going to be 2 metres above 20, so 22, and 18. All right, so they're quite wickedly different. It really is a small one. All right, so that's the middle of this one. So in our large and small, large, small. We're going to start with A. So A for the large one is going to be 50, and this is what you need to write. 50, the highest, minus the lowest, divided by 2. All right? $34.17. So 17 metres is the windmill that's. And the other one is from 22 to 6 to 18 divided by 2 equals 2. We can't have been told that. All right, next, where is the middle? Okay, so in this one, we're talking about D here. In this one, it's the lowest point plus A. So it's 18 plus 2 is 20. That's where A is and what A is. In this one, the lowest point is 16 plus 17 equals 33. That's the middle of this one. All right? So we've now got A and D. The next one is B. So remember, B is about our period and our frequency. So in the large one, the sails of the large windmill make 5 revolutions every 200 seconds. 200 seconds is how much? Minutes. 200 seconds divided by 60, 180.
3 minutes, 20 seconds.
So 3 1/3 minutes, right? Now you could do frequency in seconds, or you could do it in minutes. I've chosen to write 5 there, so I'm doing it in minutes. So 5 revolutions in 3.5 minutes. So 1 revolution in what? Is 1 revolution 1 complete graph? Yes, right? Top to the bottom to the top. So the period of the graph is 5 revolutions in 3 1/3 minutes. So 3 1/3 divided by 5 equals the period. So whatever that is, somebody give me a nice decimal. Hello? Did you put it? 3 1/3 divided by 5. 9/15. 9, 10/15. 2/3? Yeah. Okay. So it equals 2/3. And where possible, we should try and leave that in fractions. All right? So every 2/3 of a second, it will go up and down. So here we've got the period equals 2/3. So the frequency equals, what do we do for frequency? What's that formula? 2 pi divided by P, right? 2 pi divided by P equals 6 pi over 2, which equals 3 pi. Okay. And the small one, the sails of the windmill make 3 revolutions every 4 minutes. This time I've already got my 4 minutes. So my 4 minutes divided by 3 revolutions is 1 1/3, which is fabulous. So we're just going to leave that as 4/3. So our period is 4/3. So our frequency is 2 pi divided by the period, which equals 6 pi over 4, which is 3 pi over 2. All right. So this one says that she puts the smiley face on each of the sails right at the bottom. So we are to assume that they're both starting at the bottom. So we're now up to our C. So now we have to decide when we get to C, what graph are we using to represent this? So if we draw this, what do we got? 33, which is approximately 20, 30, 40, 50. Yeah, okay, so 33. 10, 20, 33. Okay, we've got a period, a frequency of 3 pi, so within 3 pi is approximately 9.3. We can just go with the 2/3 actually. One, 2, 3, 4. 3, 3 rotations every 4 minutes. So in there I have to get 3 rotations for the little one. And we're starting at the bottom. So approximately 3. Remember, this is a sketch. I'm not expecting this to be. All right, so I'm happy with that one. Yes? We all happy with that? Starting sticker on at the bottom, starting at the 18, wriggling up and down 3 times within 4 minutes. The other one's got to wriggle up and down 5 times in 3 1/3 minutes. So 5 times in this base, and it's going from here to up there. So 5 times, oh my gosh. 1, 2, 3, 4, 5. No, that's okay. 1, 2, 3, 4, 5. Okay, there we go, that one. And we've got to go up and down from here to here. 1, 2, 3, 4, 5. So halfway in between we have to get all the way up to 50. So we have to get this going on. Sketch. Lovely sketch going on here. Who knows after that? All right, sketch. Now your sketch is being marked as part of your working. All right, so it needs to be reasonably good because it's also giving you an idea of what you're answering. So now we need, once we've got all of this, we need to figure out C. Well, they both have started at the bottom. So what would be the most sensible graph to pick? You have a choice. You can do sine or cosine. Don't do tan. Which would be the most sensible one to pick for this looking picture? Cosine. Right, cosine when it starts at the bottom or the top. Sine when it starts in the middle. Okay? One of them is likely, usually, to start at the top or the bottom or the middle. The other one may start at a weird place. But it's upside down. So this is going to be a negative cosine graph. All right? So because it's upside down, which of these letters is going to change to a negative? Which letter? Good, A. So this is going to be negative 17 and negative 2 to give us that upside down. Upside down cosine. Now, you can pick a sine graph. The sine graph starts here, all right? So it's always, to get it back to here, all right, we have to add on. So this has been moved this way. So with x, when we move a graph this way, it's a negative, right? We have x minus 3. That means move this way 3. Remember, it works in opposition to what you think. So this would be moving this way a quarter of the period. So we could have had a sine graph starting here, because then it goes up, with C equal to, so cos, we don't need it, because they're both starting at the bottom. With sine, we do need it, and it's going to be, this one is going to be a quarter of the period. Plus a quarter, no. Minus a quarter of the period. All right, this one is going to also be, sine will be minus a quarter of the period. But we don't need both. I think there's one of these that says you have to know, you have to actually find all of them. Right, so what have we got? So this part here, we're getting pretty close to achieved. Not quite there yet. All right, this is what we are practicing the death out of so that it just comes naturally. We just need to write the equation. So we're going to call this height and this time. Height equals, starting at the beginning, 4L, A, negative 17. What graph? Cosine. What's B? 3 pi by T. Is there a C? No, because we're using cosine. Otherwise, we'd have to put the T in a bracket. And D plus 33. All right? So it just falls into the ABCD pattern. This one. So large, this is small, equals height equals -2 cosine, 3 pi by 2 for B, T, no movement, plus 20. Right. Now all we need is one interval correct and we've passed. Actually, we only needed one of these equations correct and we've passed. Right? But usually they fall out quite nicely together. Right, so you are to form equations for both of them. Done. And use this to determine how long the sticker is above 21 metres in the small. So the small is here. In the 5 seconds, how long is it above? So we get our calculator and we draw it. And we make sure the picture on our calculator applies to the example. So we turn it on, we make sure it's in radians because we've been teaching degrees somewhere else. And we get to radians and we go to graphs, clear everything out. And we load in, and we can load everything in here if we want to, but let's just do the first question, which is how long is the sticker above 21 on the small? So small greater than 21. How long? And we can assume that it's in the 5 minutes. All right, so we put our graph in, so I'm going to just put the small one in from the equation, which is there. Okay, -2 cos bracket 3 pi divided by 2 bracket t, which is x, plus 20. And we need it bigger than 21, so that's on our second line. All right, so that's what we're putting in our calculator. All right, so you can check it when you get home. All right, so now we need to draw it, and before we draw it, we need to view window it. So we want a picture looking rather like this, as much as we possibly can get. So this minimum point down here is 16. So if it's 16, which is actually up here, but that's all right, I missed it. We don't probably need, let's go with the x being minimum of 0. No, we'll go with -1. And the maximum of 5.1, just so we get our 5 minutes in. And then the y minimum is going to be just under the 16, so 15 up to 51. I want as much of the picture as possible on my screen. Now I draw it. All right, and I've got a wriggle. Looks very, very similar to what I've got on the board. So now I want to find the x part of these, because that's the time. I want to find that. And do I really need to find all of them? No, I don't. It says how long in the 5 minutes. So I just need to find one of them because it's repetitive. It's a periodic function. Therefore, I only have to find one and multiply it by 4 because I can see there are 4 on my graph. All right? So I need this point and this point for x. So I use Shift G solve. And the first one is Shift G solve intersection. No, that's not my first one. Neither is that. 0.44, 4, lots and lots of 4s. So what is that really? What number is 0.44444? Right, 0.4444 is 4/9. That's his actual real answer. This is an approximate. Not that it matters, because we are dealing with a practical situation, so we will be. And then if I push it again, that's the first answer. The second answer is 0.88888. Or 8/9. So the interval is from 8/9 minus 4/9 equals 4/9, or 0.44 seconds, no, minutes to 1 to 2 dp. And it happens 4 times. So 4 times 0.44444444 is, might want an extra one just in case, menu 1 4 times 0.44, I shouldn't have to do this, but I am doing it, equals 1.776 minutes. All right? So for 1.776 minutes, the small windmill is going to be above 20, the sticker is going to be above 20. Now that is a pass. All right, we didn't need to do this to be a pass. We could have just done one and we would pass. If there is one thing that we need to solve, which there usually is. So now we return to the question, how long is the large one above? So we can just add that in. Large one, oh, is it smaller? Yeah, both are above, good. Above 40, so we now just go back and set it up again. And so when you've got your calculator with the function on them, I'm going to add them into number 3 and 4. And by pushing select, I can say that I don't want those two. It'll turn the equal sign off and they won't turn up on my picture. I'm going to keep them for later in case I need them. So when y equals 3, I'm going to add in the large one, -17, cosine, bracket, 3 pi, bracket, t, plus 33, and 40. Okay, now I'm going to draw that. I don't need to change anything because I've set all my graph up beautifully. So where is my line? 40. Where's my 40 line? Why hasn't it appeared? Did I put it? Oh, I put 400. That's why it hasn't appeared. It's 400, slightly too big. 40. Okay, there it is. And I want when is it above, which is lots of times, right? La 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 la. Every time it's exactly the same interval. So I'm going to find the first two. So x1 will be G's of intersection, not a negative, not that negative, not that negative. I'm having that positive. 0.217, no 2, and x2, 0.455. Okay. So I need to subtract those. 0.455 minus 0.212 equals 0.243. Now I need to work out how many. 1, 2, 4, 5, 6, 7. Oh, 7 and some. This is why this one's a little bit harder. So there are 7 full ones, but I need to go to the last one and find out where it finishes. Because it looks like it finishes at 5. Doesn't quite get there. So waltzing right along.
You have to keep pressing the button and waiting.
Yeah, which is why the white ones are better than. So when I get to 4.87, I'm at x. X15 equals 4.87 8. But x16 needs to be 5.
Yeah.
All right, so there's the little weeny teeny trick that might not get you merit or excellence, depending on what you do for excellence. They can count for merit. All right, so there's a lot of drag down effect in this one, but you do have to set up equations and solve. So this one equals, so x16 minus x15 equals 0.122. So I've got 7 times 0.243 plus 0.122 equals 1.823 minutes. Okay. So what next? So the last one is your excellence, because it's dealing with both graphs and an interval. So in the last one, we're looking at where are they both above 19. So we're looking for where in this beautiful picture are they both above? Both above. So here's the large one above, and here's the small one. The large one's still above. But here, at this point here, no, this one. This is where having the graph helps. Because sometimes, so they're both above here, between here and here. The next time they're both above is here. No, here. And here. Can you see that? So at this one, they're both above. This one's on, this one's above. At this one's above, this one's on. At this one's above and this one's on. At this one, I go to here. Oh no, it's here. They're both above. This is the one where it gets tricky. Ooh. So at this point here, they're both above. And this point here. Sometimes though, it's actually the one on the graph. So it's not always the one on the line. Sometimes we have to look at it to see if it's the one on the graph or the one on the line. So it's easier to see on your calculator than on that sketch. So we go back to our graphing function and we turn on the graph from 1. So we select it again and we deselect the 40 and we add in 19 and then we draw. Okay, there's that wiggle. All right, there's that wiggle. Oh, yes, okay. So we need to find all the points where both of them are above. So on your calculator, now you've got 3 things showing. You turn them on and off. You turn them on and off by selecting them with the EXE button. So if you select the first 2, it will come up with Y1 and Y3 as the equations at the top and when they intersect. So you need to figure out what it is you're trying to solve here. So the first one I want to solve is between the small, which is Y1, and the 19, which is Y5 on my calculator. So I need to go back out and draw it and intersect and select Y1 and then go down to Y5. So the first point that I want is there, which is 0.2222 on my calculator. All right. So to some extent, we're not interested in any of this anymore, so it might pay to get rid of that by changing the view window and going from 51 to 22, so you can actually see what's going on. And draw it again, and actually I might stretch it out and do this half first. Now, one of the things that we need to look at in this particular assessment is, when do these two graphs start repeating themselves together? So when this graph here, this one here, had a period of this long, 3 pi, its frequency is 3 pi, this one's frequency is 3 pi by 2. We're looking for when, so there will be 2 times, let's have a look, 2/3 and 4/3. So it should repeat every 2, right? So here, the graph should repeat, because this one happens in 2/3, so in 4/3 it's gone twice, and this one has happened once. All right, so we're looking for the lowest common multiple. So the LCM here is 2 pi, 2/3, and 4/3 is 4/3. So we only have to find the answers in 4/3, and then it'll be the same all the way along. All right, so we don't need to go finding every single one. We just need to find the lowest common multiple between the two periods, and we'll find them. So let's just make it 4/3, so we've got a better picture. Going to 4/3 on X, so that's about 1.3. I'm going to go to 1.5 so I can see it clearly. And draw again. Right. Yeah. Actually, I might get rid of that -1. So I'm going to go and view and do it again and go from 0. Draw. All right. So once I've changed that and only got one repetition, so I have enlarged this much on my graph by using the view window. I've enlarged from here to here and up to about here. And it looks like this. Right? So that's what that square box looks like. And so that's the 19. This is the small, this is the large. It keeps vanishing off the top because I've cut the tops off, because the tops aren't part of my equation. What I'm trying to find now is how long within the 5 months are both above 19. So knowing that they're both, so this is 4 pi by 3, that it repeats. So knowing that, I can see that they're both above from here until here, when this one goes below, and from here until whatever that point there is, which is actually on this side of it. All right? Can you see that? Now that I've made it big. So they're both above here. This one's gone shooting up here somewhere, and this one's going up. And it's still above when this one's come down. So that period there, they're both above. There's nothing below. Right? And from here to here, they're both above. Nothing is below. Yeah? And obviously these will be the same because they're actually symmetrical. So I need to find this much and multiply it by however many of these graphs fit in my 5. So I've got 4 graphs in my 5, I think I've worked out. They repeat every, what is this? Small. 4/3, 8/3, 12/3, 21 thirds. Oh, so it goes off the picture a bit. So there's a little bit something happening here that I might have to investigate because it goes off the picture. All right, so I have to find that one little interval and then go, there's 1 of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 5 of them, 6 of them, 7 of them, and I have to figure out what's going on here. All right, can you see that? Now you've got to get as good at this as so that you can get this all done in an hour, which you can. And that's why we're doing lots of practice. So the hardest bit is this bit here, making the picture look good. Now I'm contemplating whether we do all of this and the sketch and then you get your devices out and you draw, or you have your devices ready to go, and you draw this in Desmos. Now what Desmos will do for you is it will find all these little dots and crosses without you having to go across on your calculator. You can have your calculator or you can have the Desmos. All right, but if you're using the Desmos, then you will need to actually have that evidence as part of your solving. Okay? So we might have a go with Desmos one day. We're not going to start off with it. We're going to try and get good at it first and then add in the Desmos. Happy? We've never done it before with Desmos. But I figure that it is technology and we should